Hi, Mr. Richards here, and today's lesson is on more two-step equations. Our real-world link is on museums. A new exhibit about dinosaurs is being constructed. The exhibit is a rectangle that is 36 feet long. It has a perimeter of 114 feet. Follow the steps to write an equation that can be used to find the width of the museum exhibit. Step 1. Draw a diagram to help visualize the exhibit. Label the length and the width. Let W represent the width. Well, here's our diagram. W is our width, and we're told the rectangle is 36 feet long, so we're labeled at 36 feet. It says write an expression that represents the sum of the length and width of the exhibit. Well, if our length is 36 plus our width of W, that's 36 plus W. Write an expression that represents twice the sum of the length and the width. Well, we need to take our 36 plus W. We're going to end up multiplying that by 2, since there's, well, twice the sum of the length and the width. 36 plus W does need to be in parentheses, so you're multiplying the whole thing by 2. Then it says write an equation that represents the perimeter of the exhibit. Well, for this, we have 114 feet. And 2 times the length and the width is the perimeter. So we can say, okay, 2 times the quantity, 36 plus W, that's the perimeter, equals 114, also the perimeter. So 2 times the quantity, 36 plus W equals 114, is an equation we can solve to find the width of the exhibit. And we'll learn how to solve equations like this today. So an equation like 2 times the sum of W plus 36 equals 114 is in the form P times the quantity X plus Q equals R. It contains 2 factors, the P and the X plus Q, and is considered a two-step equation. Solve these equations using properties of equality. We'll go down to this method 2 algebraically here. And notice, for 3 times the quantity, x plus 5 equals 45, you may be tempted to distribute here. You may be tempted to get, all right, this is distributing 3x plus 15 equals 45. And then you would subtract 15 from both sides and get 3x equals 30. And then you could divide by 3 on both sides to get your x to equal 10. And you could. I mean, technically there's nothing wrong with solving the equation that way. But there is an easier way. Notice, they took this 3 and they're dividing by that 3 on both sides of the equation. This ends up canceling out here. And so that all we are left with is x plus 5 equals 15. Subtract 5 from both sides and you get x equals 10. Now you may be going, wait, how does this work? Well, if you just had something like 3 times x equals 45, how would you solve that? Well, you would divide by 3 on both sides and get x equals 15. Well, this isn't too much different. I mean, this is 2 factors, 3 times x. This is 2 factors, 3 times x plus 5. And so if we can divide by 3 on both sides here, we can also divide by 3 on both sides here. What about 5 times the quantity n minus 2 equals negative 30? Again, could you distribute? Sure. But we can also divide by this 5 on both sides, and we're left with 2, or n minus 2 equals negative 6. Add 2 to both sides, and n equals negative 4. Again, you could distribute, but you're going to be dealing with larger numbers and more steps if you were to do it that way. Let's try a few of these on our own. So we have 2 times the quantity x plus 4 equals 20. Well, let's divide by 2 on both sides and see what happens. If I divide by 2 on the left side, I need to divide by 2 on the right side. This cancels out, On the left side of the equation, I am left with x plus 4 equals, on the right side of the equation, 20 divided by 2 is 10. Now all I need to do is to subtract 4 from both sides. This cancels, and we're left with x equals 6. Now it is good to know the check step. Our directions may not say to check here, but it's still good to do. You can check every single equation you solve. And why would we want to do that? That's a lot of work, right? Well, yeah, but there's very few things in math that you can check and know for certain whether or not you're right or wrong. And equations are one of them. So if we make our substitution 6 in 4x into that original equation, 6 plus 4 is 10. And 2 times 10 is 20. So 20 equals 20, and our solution is x equals 6. Again, could you distribute here? Well, as it shows there, yes, you can distribute, and you can get it to x equals 6 that way as well. But look at the numbers you're dealing with in both options. Option 1, where we're trying to divide by 2 on both sides here, ultimately we're subtracting 4 from 10. Pretty simple. But here, we're getting the 2x and the 8 and the 20, so while we can still work with these numbers, I think it's easier to work with these numbers over here than it is these numbers over here. So as we're practicing this today, let's make sure we're dividing here first. What about 3 times the quantity b minus 6 equals 12? Well, let's divide by that 3 on both sides of the equation. Divide by 3 on the left side. Divide by 3 on the right side. This ends up canceling. We're left with b minus 6 equals 12. Well, what's the opposite of subtraction but addition? So we'll add 6 to both sides here. This ends up canceling, and we're left with b equals 18. Does it work? Let's check to find out. 3 times the quantity b minus 6 equals 12. Substitute in the 18 for b. Minus 6 equals 12. 18 minus 6 is 12. And 3 times 12 is 12. No, that's 36 equals 12. That's not equal. There's a mistake. Can you find the mistake? I can. Right here. 12 divided by 3 is not 12. And that is why our check step is so important. I see so many times again, still, where we'll get it to this part here, and we'll say, oh, 12 equals 12. I've got the right answer. B is 18. No, it's not, because 3 times 12 is 36, and 36 does not equal 12, so B is not equal to 18. So let's restart this real quick to make sure that we can find the right answer. When we divide by 3 on both sides, this cancels, and I'm left with b minus 6 equals 4, because 12 divided by 3 is 4. Then, when we go to add 6 to both sides, we get the answer, after this cancels, of b equals 10. Now, just because we redid it doesn't necessarily mean we're right, so let's still check this. Rewrite our original equation. Make your substitution in. And 10 minus 6 is 4. And 3 times 4 is 12. 12 equals 12, so b does equal 10. So again, I know this took us another minute, but please, please be honest in your check steps. Be honest in your check steps to make sure we do have a true statement at the end. This time we did. Here we didn't. Be honest with yourself, and you'll always be able to solve equations the right way. Why don't we try this one on our own? Negative 7 times the quantity 6 plus d equals 49. Go ahead and pause your video, give it a shot, and then unpause to see if you got the correct work and solution. If you got it so far to 6 plus d equals negative 7, since you divided by negative 7 on both sides, so far so good. If after you subtracted 6 from both sides, you got d equals negative 13, we might have the right solution, but make sure we show our check step. And after rewriting our original equation in our check step, making our substitution of negative 13 in for d, 6 plus negative 13 is negative 7, and negative 7 times negative 7 is a positive 49, and so we have the correct solution at d equals negative 13. Now, what would this look like if you did distribute instead of dividing by negative 7 to start the problem? Well, it looks a lot more difficult. Because after distributing, you would have negative 14 minus 7d equals 49. Then after adding 42 to both sides and dividing by negative 7, you'll still get d equals negative 13. But again, look at the difference between the ease of solving this question versus solving this question. This is easier, and it's meant to be. So let's make sure we're practicing it that way when we can. Now, I know fractions and decimals can be scary things when using these in equations, but if you follow the same steps that we did with the integers in the previous examples, then it'll be fine. In our example, 2/3 times the quantity n plus 6 equals 10. We don't need to distribute. That would make it very difficult. Instead, we can multiply by the reciprocal on both sides. This comes down to n plus 6 equals 15, and just subtract 6 on both sides to get n equals 9. Again, it looks a bit more complicated than it actually is. In our example 4, 2/10 times the quantity c minus 3 equals negative 10. If you start off by dividing by the 2/10, this will cancel, and negative 10 divided by 2/10 is negative 50. Add 3 to both sides, and you get c equals negative 47. So it looks a bit intimidating, it may look a little bit scary, but if you break these problems down, you'll be just fine. Our first one, 1/4 times the quantity d minus 3 equals negative 15. And again, in our little note here, reciprocal is the product of a number and its reciprocal is 1. So let me rewrite this so we have a little bit of room to do some work. 1/4 times the quantity d minus 3 equals negative 15. Again, instead of dividing by 1/4 on both sides, where we will eventually have to keep change flip, let's just multiply by the reciprocal of 1/4, which is 4 over 1, or just 4. Because if we multiply by 4 on both sides, this cancels, and we are left with d minus 3 equals negative 14 times 4 is negative 60. And now we have a one-step equation. Add 3 to both sides. This cancels, and we're left with d equals negative 57. And that's the answer. That's it. We multiplied by 4 on both sides, which is the reciprocal of 1/4. Then we added 3 and had our solution. Now again, we do need to show our check step. So rewrite the original equation, 1/4 times d minus 3 equals negative 15. Make your substitution in for d, which is negative 57, minus 3 equals negative 15. 1/4 times negative 60, as negative 57 minus 3 is negative 60, equals negative 15, and 1/4 of negative 60 is negative 15. And our solution is d equals negative 57. And how would this look if you decided to distribute this? Well, a little messier. I mean, just looking at 1/4 d minus 3/4 equals negative 15 can be a little bit intimidating, but it's still solvable. Again, after adding 3/4 to both sides and getting negative 14 and 1/4 into an improper fraction, then multiplying by 4 on both sides, simplifying, you still get d equals negative 57. But again, this way on the left looks so much more simple than dealing with the distributive property when you don't need to use it. 75 hundredths times 6 plus d equals 12. Well, let's divide by 75 hundredths on both sides. This cancels, and we're left with 6 plus d equals 16. And then subtract 6 from both sides. Cancels. D equals 10. And does this work? Well, in our check step, 75 hundredths times 6 plus d needs to equal 12. So 75 hundredths times 6 plus 10. Not the best plus sign there, but 6 plus 10 needs to equal 12. 75 hundredths times 16 needs to equal 12, and it does. 12 equals 12, so d does equal 10. Now this one looks a little crazy. The 5/9 is on the right side of the parentheses. Can we rewrite this as 5/9 times t plus 3 equals 40? Well, are we allowed to rewrite 2 times 3 as 3 times 2? Do we still get 6 both times? Sure. So we are allowed to switch these two that we're multiplying. And so now multiply by the reciprocal. And in order to do this, I'm going to rewrite this 40 as 40 over 1. So when I multiply by 9/5 on both sides, I can more easily line things up in order to cross-simplify, since this will cancel. And now when we look, before we multiply these, we should look to see if we can cross-simplify. Obviously, the 1 and the 9 are already simplified, but the 40 and the 5, we can divide both of those by 5. 40 divided by 5 is 8. 5 divided by 5 is 1. So what we're left with after this kind of combined step here is t plus 3 equals 8 times 9, which is 72, as that would be 72 over 1, which is just 72. Then we can subtract 3 on both sides, and the plus 3 minus 3 cancels, and we're left with t equals 69. Now, does this work? Well, let's rewrite our original equation, t plus 3 times 5/9 equals 40. We're saying t is going to equal 69, so we'll put in 69 for t plus 3 times 5/9 needs to equal 40. Now, 69 times 3 is, or 69 plus 3 is 72. And I'm going to rewrite that over 1 times 5/9 needs to equal 40. Because in order to multiply these fractions, I can cross-simplify. Divide both by 9, and you get 8 and 1. And 8 times 5 is 40 over 1, which is just 40. And so 40 equals 40. And our answer, solution, is t equals 69. Now, in our guided example here, Jamal and 2 cousins received the same amount of money to go to a movie. Each boy spent $15. Afterward, the boys had $30 altogether. Write and solve an equation to find the amount of money each boy received. Well, if m is the amount of money each boy received, that's what we're looking for. M minus 15 is what each spent. There were 3 of them, so 3 times m minus 15 is going to equal the $30 they had altogether. And we can solve this like we've been solving all of these. Divide by 3 first. You get m minus 15 equals 10. Add 15, and m equals 25. So each boy received $25. And, of course, when you go to check this, as we rewrite our original equation here, let's make sure it makes sense. Put in 25 for m. So each boy received $25, and they spent the 15. So each boy had only $10 after the movie. There are 3 boys, so 3 times 10 is 30, and that all works out. That is it for this lesson on more two-step equations. Good luck.